Alrighty, so as we are reviewing for our Chapter 6 test, we kind of break it down section by section, because there is a lot that we have to cover. So, Section 6.1, evaluating nth roots and using rational exponents. So, the first thing that we learn to do is go back and forth between rational exponents and radicals. So we first want to, in our first problem, rewrite them into root operations, and then simplify as much as possible. So in A, we are going to change that to the cubed root of 8 squared. Now remember, you can either do the squared on your 8 first, take the cubed root of 64, or you can take the cubed root of 8 first, which is 2, and then square that. We get 4 either way. Order does not matter in that particular case. Example B, we would first want to simplify that 81 to the negative 1/4. So that'll be the 4th root of 81 to the negative 1st. Again, you can either do 81 to the negative 1st first, or you can say the 4th root of 81 is 3, and 3 to the negative 1st is 1/3. So we're going to bring that 6 down with us. 6 times a third would give us 2. And example C, negative 64 to the 2/3. That means that we want to take the cubed root of negative 64 and square it. Or again, we can square that negative 64 first. If we want to take the cubed root of a negative number, remember that we can do that because we can take the odd root of negative numbers. We just can't take the even root. So cubed root of negative 64 would give us negative 4. But when we square that, notice that we're going to get a positive 16 no matter what. Also, I think I had a mistake on that answer key from eBackpack. I think I wrote 8, but 4 squared is in fact 16. In example 2, solve for x and round to 1 decimal place. So example A, we are going to start by adding 11. X cubed equals 94. So we are going to take the cubic root of 94 to get our answer. Plugging that into our calculator using that math option, we get about 4.5. And in example B, notice that the first thing we are going to need to do is take the 4th root on both sides. But since we're doing an even root, remember that we will need plus or minus in front of it. We only do that for even roots. And then next we will subtract 2 from both sides. So x is negative 2 plus or minus the 4th root of 21. Well, negative 2 plus the 4th root of 21 is going to give us about 0.1. Negative 2 minus the 4th root of 21 is about negative 4.1. There are 2 answers. Moving on to section 6.2, we have our properties of exponents. So problem 3a, we are trying to simplify. We need to subtract our exponents since our base is the same. Remember that there's an invisible 1 on our 8 in the denominator. So I have 8 to the 1/3 minus 1 over 1. Well, 1/3 minus 3/3 would be negative 2/3. 8 to the negative 2/3, there's a million different ways we can write this. Let's just go ahead and move this to cubic root form. So the cubic root of 8 to the negative 2nd, well again, let's take the cubed root of 8 and then take that to the negative 2nd power. Cubed root of 8, as we've said before, is 2. 2 to the negative 2nd, that's 1 over 2 squared. So we have 1/4 for our final answer. Example B, we are square rooting 45 and we want to simplify. So when we make our chart, we are looking for perfect squares since we're taking the square root. And that will obviously break into 9 and 5. So we have the square root of 9 times the square root of 5, which would just be 3 square root 5. And example C, since we have a cubed root for both, we are able to combine our radicals since we're multiplying. So we've got the cubed root of 14 times 49 is 686. And I don't know any factors that are perfect cubes off the top of my head. So I make my chart. I've got 1, 686, nope, but 2 and 343. The cubed root of 343 is going to give us 7. So I've got the cubed root of 2 and the cubed root of 343, which is just a 7. 7 times the cubed root of 2. Okay, and then example D, same idea, where since we're multiplying like radicals, we can combine what's underneath our radical. So I'm looking at the square root of 200 times 3 gets us 600. x squared times x to the 8th, we add exponents, x to the 10th, and y to the 4th, y to the 4th, that would be y to the 8th. So we're going to talk about this as the square root of 600, the square root of x to the 10th, and the square root of y to the 8th. Well, the square root of 600 we would break down into the square root of 6 times the square root of 100, since the square root of 100 is 10. So I have 10 radical 6 that I'm going to hold on to. Square root of x to the 10th, if we change that to fractional exponents, that's x to the 10/5, which is just x squared. Same idea with square root of y to the 8th, that's y to the 8/2, which is just y to the 4th. So we combine everything outside of jail. We've got, whoopsies, 10 x squared y to the 4th, and then all that's left inside jail is that square root of 6. Example E, same idea, except now we're dealing with the cubed root. So I've got the cubed root of 189, the cubic root of x to the 12th, the cubed root of y to the 9th, and we're still going cubed root of z to the 11th. Cubed root of 189, we are going to break into the cubed root of 27 and the cubed root of 7, because the cubed root of 27 is 3. So I have 3 times the cubed root of 7 that we're coming back to. Cubed root of x to the 12th, change it to fractional exponents, x to the 12/3, which gives us x to the 4th. Cubed root of y to the 9th, y to the 9/3, that's y cubed outside of jail. Cubed root of z to the 11th, there's a couple different ways that we can think about this. Z to the 11/3 is great, but we can also say, well, that's z to the 9/3, which is going to break out of jail since 9 divided by 3 is just a whole number. And then all of our leftovers. So if I took out 9/3 and I'm supposed to have 11/3, that means I've got 2/3 left over. So this z to the 9/3, we said changes to z cubed, and then z to the 2/3, that's going to go back inside jail. So that's the cubed root of z squared. So then altogether, our things outside of our radical, we've got a 3, an x to the 4th, a y to the 3rd, and a z to the 3rd. Inside our cubed root, we've got 7z squared. Final answer. And example F, in order to be able to combine these radicals, they need to be like radicals. So we're dealing with square roots again. So we've got the square root of 162, which I can break into the square root of 81 times the square root of 2. And the square root of 81 is 9, but let's not forget we've also got this 2 right here. So we've got 2 times that 9 we just broke out times the radical 2, which gives us 18 radical 2. Square root of 147, we call the square root of 49 times the square root of 3. And then the square root of 49 is, of course, 7. And we still have that negative 8 in front of it, so it looks like I've got a negative 56 radical 3. And then for radical 50, that square root of 50 becomes the square root of 25 times the square root of 2, and of course the square root of 25 is 5. So we've got 4 times 5, we've got 20 radical 2, that's positive. So we combine only our like radicals. That's our 18 radical 2 and our 20 radical 2. That leaves us with the 38 radical 2 minus that 56 radical 3 that can't be combined with anything else.